Greetings from the back, everyone. We are now delving into the fascinating realm of Neuralink, the revolutionary brain-machine interface technology developed by Elon Musk. Get comfortable as we explore the intricacies of this groundbreaking invention that will fundamentally alter how we communicate with one another and with technology. Imagine living in a future where you can operate your computer, smartphone, and even car with just a simple thought. Doesn't that sound like science fiction? Well, this future ideal is rapidly coming true because of Elon Musk and the Neuralink team. However, how does it operate? Let's investigate. Introduction to Neuralink. Led by visionary entrepreneur Elon Musk, Neuralink is at the forefront of the intersection of neuroscience and technology. Neuralink, which was established in 2016, signifies a paradigm change in how we think about the human brain and how artificial intelligence might use it. Neuralink essentially aims to create direct interfaces between the human brain and external technologies in order to close the gap between biology and technology. Neuralink aims to unravel the mysteries of the mind and utilize it to its fullest potential for the benefit of humanity through inventive developments in neurotechnology. The fabrication of incredibly thin threads, finer than human hair, that are intended to precisely interface with brain neurons is the first step in Neuralink's journey. These threads function as channels for recording neural activity and activating particular brain regions since they are fitted with tiny electrodes. The implantation procedure, which is enabled by state-of-the-art surgical robotics, guarantees minimum invasiveness and maximum efficacy, opening the door for the smooth integration of man and machine. Neuralink creates bidirectional communication channels that let the brain to communicate with external devices, opening up a world of groundbreaking applications that were previously only found in science fiction. Neuralink's aim to decipher the workings of the human brain ushers in a new era of neurotechnology possibilities. Through the process of interpreting the brain's complex neurological patterns and language, Neuralink hopes to unleash previously unattainable levels of human potential. Neuralink's revolutionary impact promises to change the healthcare, communication, and beyond landscape by restoring lost capabilities, improving cognitive capacities, and enabling seamless engagement with technology. Nestled on the precipice of this exciting new universe, Neuralink invites us to discover the infinite possibilities of human creativity and inventiveness. How Neuralink works. A complex network of incredibly thin threads, each thinner than a human hair, that have been painstakingly engineered to interface with the complex neuronal networks of the brain, is the foundation of Neuralink's groundbreaking technology. These threads, equipped with a variety of tiny electrodes, have two functions. They can both stimulate particular brain regions in real time and record neural activity with unmatched accuracy. Neuralink's threads provide the foundation of a new brain-machine interface that has the potential to change human-computer interaction as we know it through a mix of cutting-edge engineering and superior material science. Modern surgical robots makes it easier to implant Neuralink's threads, guaranteeing unmatched accuracy and security. The surgical robot navigates with sub-millimeter accuracy to implant the threads into specific brain locations, guided by sophisticated imaging techniques like CT and MRI scans. This minimally invasive method speeds up recovery and lowers the risk of problems, allowing patients to smoothly integrate with the Neuralink system. By creating a direct line of communication between the brain and external devices once implanted, the threads pave the way for a mutually beneficial partnership between biology and technology. Neuralink's brain-machine interface facilitates real-time, bidirectional communication between the brain and external devices through the use of complex algorithms and neural decoding techniques. Neuralink's system can transform the user's intents into executable commands by deciphering the neural signals captured by the electrodes. With the potential to enable people to go beyond the constraints of their physical bodies and discover new horizons in human potential, Neuralink's revolutionary technology holds the promise of enabling people to manipulate prosthetic limbs with unparalleled dexterity and interact with digital devices simply by thinking. Applications of Neuralink. Neuralink has the potential to be used in many different domains, including healthcare, communication, and more. These applications could provide game-changing answers to some of the most important problems facing humanity today. Neuralink has the potential to transform the way neurological illnesses are treated, making healthcare one of the most promising applications. For those with disorders including epilepsy, Parkinson's disease, and spinal cord injuries, Neuralink's technology provides new hope by directly interacting with the brain's neural networks. Neuralink offers the ability to restore lost capabilities and enhance millions of people's lives globally by precisely stimulating specific brain regions. Neuralink's technology offers significant opportunities in the field of cognitive improvement in addition to its therapeutic uses. Neuralink can improve memory, learning, and problem-solving skills by utilizing direct neural connections to supplement the brain's inherent capacities. Imagine a day in the future when people can simply recall a tremendous amount of material with a single thought, or when pupils can upload knowledge directly into their brains. Neuralink pushes the limits of human mind to new heights, enabling unprecedented levels of creativity and intellectual capacity. Neuralink's technology has significant implications for communication and human-computer interaction in addition to healthcare and cognitive enhancement. Neuralink holds great promise to transform human communication and connection by facilitating direct brain-to-brain contact. Neuralink's transformative impact on communication has the potential to bridge divides and foster deeper connections in an increasingly interconnected world. It can enable telepathic communication between individuals as well as seamless communication for those with speech or hearing impairments. Challenges and ethical considerations. Although Neuralink's technology has enormous potential, its development and application present a number of difficult problems and moral dilemmas that need to be carefully considered. Concerns about data security and privacy are among the main ones. Ensuring the privacy and security of users' neural data is crucial, as the information gathered by Neuralink's brain-machine interface is intimate in nature. In the absence of strong security measures, there is a chance that personal neural data may be misused, accessed without authorization, or exploited, which could have detrimental effects on people's moral and legal standing. Furthermore, concerns regarding informed consent and bodily autonomy are brought up by the intrusive nature of Neuralink's implantation method. While the technology developed by Neuralink promises to bring about revolutionary changes, such as the restoration of lost functions and the improvement of cognitive capacities, people must have the freedom to decide for themselves whether or not to undertake the operation. Respecting moral principles and defending people's freedom to self-determination require that people are fully aware of the dangers, advantages, and ramifications associated with Neuralink's technology. Furthermore, the extensive use of Neuralink's technology has the potential to worsen already existing inequities and inequality within and between countries. There may be differences in access to state-of-the-art medical treatments and cognitive enhancements due to issues including cost, availability, and healthcare infrastructure, which could limit access to Neuralink's advanced neurotechnology. Proactive steps will be needed to guarantee fair access to Neuralink's technology and reduce the possibility of escalating already existing social and economic inequities in order to address these imbalances. Transparency, accountability, and inclusivity must be given top priority as we negotiate the moral challenges presented by Neuralink's technology in order to guarantee that the advantages of neurotechnology are distributed fairly and ethically. One thing is certain as we get to the end of our exploration of Neuralink: the future is here. We're seeing the beginning of a new age in human-machine interaction, led by Elon Musk and Neuralink. What do you think about Neuralink then? Do you have worries about its ramifications, or are you thrilled about the possibilities it holds? Please share your thoughts in the comments section below, and don't forget to subscribe for more incredible material on the newest developments in technology. Until the next time, continue to be inventive and curious. I'm going to miss you.